All right, folks. Back to Java versus Rust um, video series, however you call it. So this time we are going to focus on how Rust manages the memory during runtime versus memory management in Java during runtime. So remember the keyword here, runtime, for Rust and runtime for the Java, right? And we are pretty familiar with garbage collection if you have been programming in Java and any other programming language. They use that similar concept. So in this demo, I won't be going through the coding tutorial because it will be sort of um, less explanatory if I explain via code. So I gathered some help from the AI to create some um, uh, animation. That way, it's easy to follow through. All right, so let's start with the animation, and then we can go from there. Actually, alrighty, let's go right here, and all right. So let me make this a little bigger. Okay. All right. So for the Rust and Java, right? So the one on the left you have is the Rust and one on the right is the Java. So now imagine this box is the memory space, uh, um, location, right? So imagine this like as a chessboard, for example, and that has certain memory location to it. And same thing with the Java, right? You know, small boxes that holds the memory location of particular object. So what do we know so far? We know that this data A or an object or whatever you call it, entity, um, is taking a piece of that memory, right? Now, same thing with the data B. It is taking a piece of that particular memory. And let's say this is running in some 3 gig of memory, right? Now, obviously, in a production ready programming, there will be millions of objects. So it will be million spaces being occupied, right? So now same thing with the Java, right? This particular object X, Y, Z, it's obviously taking some spaces in this particular memory, right? Imagine, so I'm like, so this box can be considered as a 3 gig of memory and 3 gig of memory, right? So now I have this written here that says it has exactly one owner and no garbage collection needed. Now in Java, based on the references, multiple references, garbage collection kicks in and cleanups, right? So in the Java side of things, if the object is not used anymore, no references there, and whenever the garbage collector collection clicks in, kicks in, it cleans up the objects. That's at a very high level. Now let's say data a job was to assign some variable to it, like some string, and then it's done. Now what happens is this data a that own the part of that Rust memory location gets freed off, right? So frees up meaning it's the ownership has not been uh, surrendered. It's just transferred over. Okay. There's a big difference here. Though. Keep in mind that it's just that data is saying, okay, my part is done here. Anyone who wants to take this, I am ready to transfer it over to you. Right. So And let's say we have another data, another object, another process, data B. Now data B wants, because see, there's like millions of objects, right? And then let's say this data B also needs some space on this ownership, right? So data B is going to say that, hey, data A, I see that you are done with the ownership of owning that memory location. Can I borrow it for a second or whatever the process it has? So it borrows that memory location, and then after it's done, it's going to return it back to the original owner. Okay. And the original owner might not need it actively, that's fine, but that particular memory location is always going to be saying, like, assigned to saying, hey, this, the original owner of this memory location is data A. Now, likewise, there will be many active objects and many inactive objects, right? So two different things. There's a very, very, very less, like rare chance that all of the objects are busy, and then there's no memory location available and all that. That's very rare, and I don't see that happen. So now what's the benefit, you might ask, right? So for the benefit part, we'll go later. I'll explain it in detail, at a very high level, actually. Not in detail, because I am not the guru of the CPU and memory, uh, right? So, but at a high level, I can briefly go through. Now let's switch to Java, right? So with the Java, the garbage collection kicks in, right? Let's say object X was referencing G, and object Y was also referencing G, and then the reference is done. Whatever the process need to, whatever the method was needed to call, it's done, completed, and then the garbage collection kicks in. Now the garbage collection will go ahead and clean that space, and then any random object can come and will be assigned the memory location, right? So now, what's the benefit of all this? So with the ROS, right? So since data A is strictly provided the ownership for that particular location of in that memory, it improves the security. It's not, there's no randomness, right? Just in Java, once that reference is cleaned up by the garbage collection, any object that needs to be running, that needs to get hold of a memory location, gets to use that. But in ROS, that's a different story. During the compile time process, during the runtime process, along with other scenarios, ROS takes care of. It's already pre assigned, right? So security wise, that's good. And then the second thing I've seen read through is the Frost is pretty good at making sure that there is less memory leaks compared to Java, right? Memory leak, because see, let's say we have 1 million objects, 1 million data, we will have 1 million ownership of that particular data in the memory. So one thing I see is um, Rust might need a little bit of more memory compared to Java, uh, but now we memory is not a big issue for us at this point, in the way we have advanced, right? So the bigger issue here is the security, right? So, but yeah, let me read through the description what I got from online Google, and the documentation. So this is what I could, I know, like, this is the very short form that I explained the animation. So Rust is a compile time memory safety through ownership rules. So as I explained, right? So the ownership rules make sure that the compile time memory safety is maintained throughout the application. No runtime overhead from garbage collection, which is true, and each value has one ownership, and ownership can be transferred or borrowed as needed. Um, and then the Java runtime memory management through garbage collection. Multiple references to the same objects are allowed, compared to the ownership rules, and then unreachable objects are garbage collected, which adds the runtime overhead. So this is how I take it. If I were to use a security intensive application, I would go with Rust. But if I were to use an application that's not security intensive and requires less memory size in context of quantity, I would go with Java. Um, and obviously, Java needs the runtime JRE installed, or at least have that on the underlying environment have that with Java application can run, whereas Rust does not need to worry about that. So you can take the owner, like the winner here itself, right? So I mean, I think Rust does pretty good compared to Java. All right. Now I'm gonna switch back to some like comic kind of animation here, just so you hopefully will make a more sense, and kind of relate to real world scenarios. All right. Okay. So let's see. Hopefully this is pulling up. Uh, all right. All right. Let's see. Okay. All right. Okay, so I will not go through the Java. If you are here all the way, I take it that you are already aware of the Java memory management. I wanted to go through the Rust because Rust has this new concept called ownership, and wanted to go through this um, a very different approach. This time with with sort of, you know, comical diagram, that I took help from AI. I gave some prompts to help it generate this kind of story here. But this is the story here. Okay. Imagine this string is an object, but in this case, this is a toy that Rusty is playing with and he owns it. His parents bought this for him. Okay. Now there comes Amelia, and then she says that she wants it. So Rusty is going to say, "Well, I own this store." And then see the ownership is established here, but then Rusty says, "Hey, I own this string toy, but yes, you can play with it. You can get the things you wanted to do. In this case, play with it, enjoy it, but the ownership still stays with Rusty." Now, when Amelia is done, Rusty did remind her that when you are done with it, return it back to me. So now, when she returns it back to Rusty, he might use it actively, or he might just hold on to it, right? So that's the part one of ownership. Um, Now let's move to the borrowing part, right? So now the things come when we have multiple moving parts, and what if, like, it has to be, what if, like, there's the request at once coming in, what happens at that time? So at that point of time, what happens is, in this case, so Rusty has its toy string. Now Miles comes in and says that he wanted to play with his toy, right? Rusty's toy. And Rusty says, "Okay, I am the owner, and yeah, you can go and play with it." Now, Emily also comes in and says, "Hey, I want this. I want this particular string toy. I want to borrow it." Um, but what happens is now Rusty will say, "Well, okay, but this is already being borrowed by Miles." Okay. Um, now, now the part, right? Moving, right? So moving part is, um, let's say we have John coming at the same time. Okay, just remember the first one borrowed the toy. The second one, Rusty said that it's already borrowed and is referenced out. So Amelia will actually go to uh, the Miles actually. It's not in this diagram, but she'll go there and say that it's referenced there. And let's say if Miles is also still working on that, playing with that toy in this case, um, Emilia will go to a different other place. And, the cycle continues and it's pretty fast. It's like nanoseconds of wait time and all. And then let's say Miles is already done, then she does not have to go back to all the references to borrow that memory location, right? Um, and then let's see if you have to change, if you have to edit that ownership. Well, you cannot change the ownership. Let's see if you have to change the references is when you create the mutable borrow. Mutable borrow means I need to change some things, right? Something like immutable objects. Let's put it that way. Or sorry, my bad. Mutable objects in this case. That way you can reference the object that you borrowed, but not the ownership. You know. All right. So just the final lesson here before we close out this video. Um, that the original owner has the right to um, give the temporary ownership to the requester. In this case, like Emily, Miles, um, and in this case, we're saying a fixture to it. But if we need to add something to that object, then it's called a mutable borrowing. All right, so hopefully this help you kind of understand the memory ownership between Java versus Rust. And once again, thank you for staying all the way to the end of this video. You guys have a great night, day, morning, wherever you are watching this video from. All right, enjoy.